Morning, afternoon, evening, or whenever. Beginnings of curve sketching. So curve sketching unit 4 has a hand in but no quiz in it. I'm not going to put a quiz in this unit. I'm going to add the unit 4 quiz to the maximum minimum unit that comes next, unit 5. Okay, so there'll be one curve sketching question on that quiz, but there won't be a specific quiz just for this unit. Okay, and the reason that is because it's related pretty closely to what we do next anyway. So we're going to ask, what are critical numbers? And I'll explain what that is. We're going to use sign analysis to find increase and decrease intervals and where local maximum and minimum values are. And we're going to have some examples to do. So what we're going to talk about is the first derivative test. And that is, if you take the derivative of an equation of let's say of a curve, and set the value to 0, that the value to 0, and then solve for x. Let's stop there for a second. Let's maybe start again. The first derivative, if you take the derivative of a curve and set the value to 0, that is called the first derivative test. The resulting values of x are called critical points or critical numbers. Okay, and I call that, I just go C, CP for critical point. If I say, okay, that's what a critical point is. Remember that the slope of the derivative represents the slope. So is the first derivative, let's go, represents slope. So max and min values can be found by looking at the changes in slope. For the curve. If we don't draw the curve out, we can just look at the values of it. So for example, if you have a maximum, which is a hill, so here's a max, and I'll put a min here. So this would be a max. And this would be down in here, wherever it's going to be a min value. So what we see here is if we take the slope right here, right at the max point, it's 0. That's a critical point because of that. And this is another critical point, the min here. But as we can see, if we go before that, if we take a point over here and touch the curve, and one right here and touch the curve, and here, touch the curve, and then run one right up here and touch the curve. You can kind of see what's happening. I'll fill that in with red dots so that we have, touches there, touches there. So there's a pattern that happens here. So this is y prime equals a negative value. Oh, what am I saying? That's not negative. That's a positive value. It's climbing up a hill. Y prime is, let's use the greater than sign. It'll be easier. So y prime is greater than 0 here. Y prime equals 0 at the max, and then y prime is less than 0. It's a negative slope. Here we have a negative slope going down again. Y prime is less than 0. Y prime is equal to 0, and then y prime is greater than 0. Pardon me. So we have a max occurs if we go y prime greater than 0 to y prime equal to 0 to y prime less than 0. So positive 0 to negative slope. We have a max, right? Positive, 0, negative hill. Okay, the opposite is true here for the bottom. Come on. There we go. All right, so here, if I go from y prime is less than 0 to, let's make it in a straight line here. Okay, so if I go y prime is less than 0 to y equals 0 to y prime is greater than 0, we have a min value. So your slope goes from negative to 0 to positive slope. So if you've got plus 0 negative, max, negative 0 plus, minimum, valley or hill. And that's how you can tell the difference between the two. So the first derivative test we're going to use to find critical points, and how you find critical points is set it to 0 and then solve for x, and then find max and mins. And how you do that is we're going to do some sign analysis. So for the rest of the day here, we're going to find intervals of increase, decrease, and as soon as we know that, we can find max and mins, and we're also going to find critical numbers. So we're going to do 2 examples of that process. Okay, so let me do this on another page here. So let's go a typical example of what I would ask you using the first derivative test. So let me get my little sheet out here with at least one good example here. Okay, so let's say that find the critical number points let's go find A period, the critical points B, the interval interval of increase and decrease in the graph. And see the max and min values, if there are any. for, let's say, y equals x cubed plus 3x squared minus 1. Okay, so that's a cubic equation that we have. We don't necessarily need to sketch the graph or use Desmos. We can do it all with calculus. And that's what we're going to. So the first thing that you're going to do, and I'm going to change to marker here. Okay, so to find critical points, the very first thing to do is to take the derivative and set it to 0. So let's go ahead and do this. To find critical points, take the derivative, which we'll just say take y prime, and set it to 0. And then solve for x. And there's a couple different ways you can find the max and min points here. I'll show you some other ways as well, other than just using that curve analysis thing that we looked at the beginning. Let me just turn my timer on so I know how far we're into it here. So we're at about 12 minutes. Okay. So y prime equals 3x squared plus 6x. Okay, there's our derivative, and then we set it to 0, and we solve for x. We have to use factoring. So a common factor of 3x can come out. So we got x plus 2. So that means, therefore, if we solve for x, 3x equals 0, or we could have x plus 2 equals 0. So that means x equals 0 or x equals negative 2. These are our critical points. Now you can find out what they are. If you put 0 back into here, it would be 0, 1, or 0, negative 1 for our critical point. And then if you put negative 2 back into the original one, you get something. And you can find out what your max and min is by doing that. But let's do it. Let's do finding the areas of increase and decrease. So how we find the areas of increase and decrease is we do something called sign analysis. So sign analysis oops, I spelled that wrong. Sign analysis to find area of increase in the graph, which means it's going upwards from left to right, and decrease, which means it's going downwards from left to right. So how we do that is pretty simple. Okay, we take and we draw a number line with our critical points on it, 0 and negative 2. Negative 2 is there and 0 is there. Then we take our two factors and we do a sign analysis of them. So we go 3x and we go, where is 3x 0? Well, 3x is 0 at the 0 point. Below that, if you pick any number below 0, 3x becomes negative. So we put the negative sign. So for example, if I take negative 1, this would be negative 3. If I take negative 6, 3 times negative 6 is negative 18. It's all negative. Above the 0, if we pick 1, 2, 3, or 4 and multiply it by 3, they're all positive numbers. We do the same for our next factor, x plus 2. So where is x plus 2? 0. Well, if x is negative 2, we get negative 2 plus 2, which would be 0. So it's right there. If we go below negative 2, like negative 3, negative 5, negative 7, we have negative numbers. So these are all negative. Above that is positive. Generally speaking, it always goes negative, 0, positive, depending on how you do it, unless your factor's got a square in it, like x squared. And then if it was x squared, it would be positive all the way across. Okay, so now we've done our sign analysis. So now the actual equation is this times this. Remember, the derivative represents slope. So where is the slope positive? Where is the slope negative? So we have to multiply the signs together. A negative times a negative is a positive from negative infinity to 2. Negative 2, pardon me. A negative times a positive is negative. A positive times a positive is a positive. So now we have our slope analysis. So it is increasing from negative infinity to negative 2. So how do we write that? Negative infinity to negative 2. We can just use interval notation. And it is also increasing from 0 up to positive infinity. And it increases from 0 to positive infinity. So there's our area of increase. In between, we have our area of decrease in here. It is decreasing. Okay, so it's going to decrease from negative 2 to 0. And there is our answers for increase, decrease. How about max and min? So now if you remember a hill, so it's going to go from positive slope to 0 to negative slope. Positive slope to 0 to negative slope. So this is a max because it's giving us one of these. Over here, it goes from negative slope to 0 to positive slope. So this is a min. Now you're like, okay, I know where my max and my min are, but what are the points? I don't know what they are. We have to find out what your max and min are. If you want the y points in it, you have to go back to the original equation. So we got to go all the way back up here to x cubed plus 3x squared minus 1. Now, if you plug the numbers in, you're going to get the max and min anyway, just by looking at the numbers. So you could just write like max is at x minus 2 and max is at 0. But if I wanted to put the y's in there, y equals 0 cubed plus 3 times 0 squared minus 1 minus 1. So we have our min at 0, negative 1. And our max is at y equals, so we've got to put in a negative 2 because that's our critical point. Negative 2 cubed plus 3 times negative 2 squared minus 1. Okay, so when we do that one, we got 8 negative here. And we've got 4 here times 3, that's 12, and minus 1. So this is going to give us 4 plus 3. So our max is at 2, negative, and 3. And you can tell because this is lower than that in terms of the y. So that would be your min and max. You could just do it by plugging the numbers, the two critical numbers, and figuring them out. You don't even really have to do the sign analysis to get the max and min. But if you plug the numbers in, but you do need the sign analysis to tell you if it's increasing or decreasing. Let's do another example. I'll see if I can find one with a squared term in it here. So just let me pause here and look for one. And I'll be right back. Okay, kind of had to make one up. So here's an example that would have x squared term in it or something like that. So let's say we had same idea, find let's okay, and let's say the curve is, and I'll do it, have to make this one up. So y equals 4/5 x to the 5th minus 4/3 x to the 3rd plus 10. Okay, so this one will work out for us, and we want to find the critical points, the interval increase, decrease, and the max and min values. So there's our original curve, so we got to do the prime derivative here. So we go 4/5 times 5x over 4, and then we go minus 4/3 times 3x squared plus 0. So y prime then equals, if we go 20 over 5, that's 4x to the 4th. And if we go 12 over 3, that's negative 4x squared. Okay, I want it to kind of work out nicely like that so that we could get some squares in there. Okay, then we set it to 0 to get our critical points. 4x to the 4th minus 4x squared. So we can take 4x squared out front. And that gives us x squared minus 1, which is a difference of squares. So this factors out to 4x squared, x plus 1, x minus 1. So our critical points then, therefore, are 4x squared equals 0. So that would mean if we take the 4 over, x squared equals 0. And if we take the root of 0, it's still 0. So x is equal to 0. X plus 1 equals 0. So x is equal to minus 1. And x minus 1 equals 0. So x is equal to plus 1. So we have critical point here, and a critical point here. If we wanted to find out what the y points of that critical point are, we could plug them into the x here. This one, so for example, 0 would be, our critical point would be 0, 10. Okay, if we put the 0 in for that and that, we get 10. These other ones are a little harder. If we put in a 1, let's do positive 1. Positive 1 here, 1 to the 5th is 1. This would be 4/5 minus 4/3 plus 10. So let's do 4/5 plus minus 4/3 plus 10. Okay, so I'll go 4 divided by 5 minus 4 divided by 3 plus 10. So I get 9 7/15. Or if we like, you can use decimals here. 9 7/15, or 142 over 15, or 9.47. So 1 and 9.47. And if we put a negative 1 in there for our third critical point, okay, so let's plug it in. Negative 1 to the 5th is negative 1. So negative 4/5 plus 4/3. So negative 4/5 plus 4 divided by 3. Okay. And plus 10. So I end up getting 10 8/15, or 158/15, or 10.53. So there's our critical points. And generally speaking, for areas of increase and decrease, you just need the x point. So let's do the sign analysis for that. So if I draw the line, we need a -1, a 0, and a +1. Our factors that we had were 4x squared, x plus 1, and x minus 1. So 4x squared is 0 at 0. Now, if you take negative numbers and square them and multiply them by 4, they're still positive. So this whole thing is all positive because it's a square in there. X plus 1, if you have x minus 1, it's 0. You have a -1. So this is negative here, positive here. X minus 1 is 0 at +1. 1 minus 1 is 0. And so it's negative below that and positive above it. So our area, this is going to be positive, negative, negative. So positive times a negative times a negative is a positive. A positive times a positive times a negative is a negative. Positive times a positive times a negative is a negative. A positive times a positive times a positive is a positive. So there's our slope analysis. So now, in order to get max and mins, you have to be careful. You go positive to negative to, or positive to 0 to negative, okay? And you go negative to positive 0. So there's a max and a min at 1 and -1. We have to decide which one is which. You can tell from here what they are. Obviously, you're going from a negative here to a 0 to a positive. So a negative to a 0 to a positive, that's a min value. And at x equal 1, so this is going to be a min. And you can tell by the size of the number, right? Negative, positive, or negative 0, positive. This one here, this is a -1, by the way, not a plus. Fix that up. Okay, so this here is our min. And this is a max because you go positive, 0, negative. So that's a hill. So at -1, you have a higher number, which makes sense, right? Okay, so areas of increase and decrease are our last little bit. So in here, it's increasing from -infinity to -1, and then from -1 to positive infinity. It's decreasing in the middle from -1 to +1. That's a +1, right? So I better put a pause. This is from +1, right? So it's decreasing -1 to +1. Okay, and again, you could just look at the numbers for your max here and your min, or you could use a little analysis in there. Okay, max is right there, higher number. Min is right there, lower number. Okay, and there's two examples of doing sign analysis. So practice stuff for first derivative practice work is up there as well. It looks something like this. Okay, do you have to do all 6? No, you don't have to do all 6, but at least do a couple, 3 of those, and then the solutions I did provide as well. Right here, I redid them here. Let me try to make them a little neater. And then your solutions are worked out there. Okay, you can see it kind of bleeds through a little bit on the scanner, but there's your solutions 1 to 6. Do a couple of those as well, and that is it for the first derivative test. As you can see, we're going to get into the second derivative test, which is for concavity next day. All right, so let's get that out, and we'll see you next day.